Hello everyone. I teach storytelling with data in the classroom. And one of the great ways to tell a story using data is the various forms of data visualizations. However, from my experience, I have found various other ways as well that helps us greatly in doing the storytelling. And I'm going to share with you one of those techniques. Now, I think most of you are already familiar with a decision tree, and I will show you how a decision tree really helps telling a story. Sometimes the story is really emotional. I'm going to tell a story from the Titanic dataset that is available in Kaggle. This is the dataset of passengers of Titanic, and the original idea is basically to predict who will survive and who will not survive. I'm going to use that particular dataset and tell you the story. What might have happened when the team was saving the passengers? What are the factors that really played behind the curtain? So what I did was I downloaded this data, and here is the definition of the columns. There is the P class, that is the class of the passenger, the sex, the age. Sibling spouse is a number of siblings or spouses. And there are other columns too, like ticket, fare, cabin, and so on. So I'm going to quickly show you how I will extract the story points from this data. I have recently created this shiny application. It's called rulesbuddy, and this does nothing but creating a decision tree from the data that we choose. So I will go ahead and access the training data from this, and you see the columns appearing here. My dependent variable is survived, so basically I want to find out what are the factors that influence the survival of the passengers. So first thing that I'm going to do is I'm going to click on P class, because most probably the class of the passenger was a very good indicator of whether a person will be survived or not. If I click on P class, I see a few points. If the P class of the passenger was C1, then there was a 63% chance of survival of that passenger. The probability comes down to 47% when the class was C2, and it was only 24% when the class was C3. So you see, as expected, how the class mattered while saving these people. But P class is not the only parameter that might have influenced the survival of the people. Let's try sex as well. And the moment we select sex, we see that there are two different patterns, male and female. The proportion of females were 35% in the ship, and the proportion of males was 65%. Out of these 35%, 74% were saved, and from the males, only 19% were saved. And that too, when that female was in C1 or C2, then the probability of survival was 95%, and in C3 it was just the half. For males, we have a similar pattern but lesser in the magnitude, 37% and 14%. Now I'm going to add one more variable to this, which is the age. When I add age, I see that there are different patterns for different ages of males and females as well. So let's start with the females. Well, the age did not matter when a female was in either C1 or C2. However, when this person was in C3, then where the female was more than 39 years old, then the chance of survival of that female was really, really low. It is just 8.3%. However, if the female was less than 39 years old, then the survival percentage was 54%. So you see how the various parameters are influencing the survival chance of a person. Similarly, for males, this is very interesting. Age is more than 6.5 and less than 6.5. That means this is the kid. If it was a male kid, then the probability of survival was 67%. However, if it was an adult male, then the classes mattered. If it was C1, the probability of survival was 36%. If it was C2 or C3, it was only 12%. I'm going to add one more variable. So you remember the sibling spouse. How many siblings or how many spouses are there in the ship? So I'm going to add sibling spouse. And that is when something really interesting comes up. For the females, if someone belonged to C3, if this female had a smaller family, then the survival rate of that female was 55%. If the female had a bigger family, then the survival rate came down to 1/3, less than even 1/3 of this. And the same story here as well for males. When it was a kid, if the kid had less siblings, then the probability of survival of that kid was 1. However, if the kid had more siblings, then the probability of survival was almost 1/10, around 1/9, and which is very interesting, and it's kind of sad that if a kid had more brothers and sisters, then there is less chance that the kid will survive. If the kid had lesser number of brothers and sisters, for example, the kid survived with more probability, which means that most probably the parents of these kids were given a choice of whom to be saved when they had more kids. You can imagine how painful that situation might be. When I have 5 kids and I'm being asked that I can save only 2 of your kids, not all 5. And it's up to me to choose which 2. I found this really interesting, unfortunate, and sad. And this came out really easily from this decision tree. So anyway, I just wanted to share this story as well as this application Rules Buddy with you. I'm going to mention the link of this application in the first comment. Feel free to use this and let me know how it works for you. Thank you very much. Have a good day.